Okay, welcome back to Hacking Pro Tips. Today is a unique day. Starting off, I guess what's a new podcast series. Jason Haddix and I had this brainchild, mostly him, coming out of the last interview that we had, where I thought it'd be a cool idea to kind of have conversation. It can be kind of lonely doing single podcasts. So we thought we'd team up and look at some cool bugs and kind of deep dive into them. This is really our first go. Who knows if the format will change, but I think, Jason, you'd agree with me. We'll kind of do this as a conversation, and then coming off of that, I don't know, maybe one day we invite some hackers onto it and talk about their bugs or whatnot, but first go, kick at the can. Thought we'd line this up and then maybe pump out another 5 or 6 and see where we go.
Yeah, absolutely. I think you hit the nail on the head. Is doing a podcast by yourself is lonely. You don't have a lot of ideas to bounce off, and as well as you've had a lot of guests on your podcast that are all-star hackers, and just wanted to kind of join a few of your deals here, and maybe talk about some bugs and thought process around them, and really less of an interview, but more of an informal kind of conversation around hacking, right? Like there's so much context that goes into how people think about this stuff. It's and it goes less said than just like the Q&A style format that we did before. So
Yeah, exactly. And I should say, I'm coming at the podcast from the great Shopify, who is nice enough to sponsor the podcast and donate some time. Jason Haddix, head of trust and security over at BugCrowd, here joining me. So I guess I should have done that at the beginning, but either way, it's said and done.
no worries.
So today, what we're going to focus on is the Facebook image tragic bug, and this was found by, and I'm going to apologize if I butcher the name, Andrei Leonov. It was found in about October 2016, and it was an image tragic vuln, which I'd like to think a lot of listeners know about, but we're going to dive into that and kind of discuss what that means. But before we do that, I just want to flag Andrei's. I mean, he's awesome, right? He's ranked 51 on BugCrowd, at least at the time that I was doing my research. That could have gone up by now. 170 vulns found there, 95% acceptance, and 2.77 average security, which is, or severity, which is pretty impressive. So big shout out to him and the write-up for giving us the material for this.
Absolutely, yeah. It's funny. I always look at his handle, and for some reason I see 4lemon, but I think it's AO11.
I definitely see 4lemon, and that's
I don't know. On BugCrowd, the 2.77 average severity rating too is really good for us. That's a great average severity rating. So I always see him on our programs, just kicking butt. So super excited to talk about this bug, honestly.
Nice. So let's kick it off on that note. So image magic, image tragic. In a nutshell, can you kind of relay to us what those two are?
Oh boy. Okay. So yeah. So image magic is an image parsing library, basically, and it will take an image and be able to resize it or do a whole bunch of different things with it. At a very high level, there was a bug found that basically you could embed binary or command line commands inside of an image file after a certain number of bytes. And so you could do all kinds of things. You could move files. You could force the server to read files. You could delete data. And so this was just a simple. It was really easy for people to understand and kind of exploit when it first came out because it was like command line hacking. Like back in the day, like you had like command injection or things like that, where you would just tack on another command to kind of what something else was already doing. And so to find this in a library that was so widely used in Linux stacks or Unix stacks was crazy. And so like everybody used this library to do image resizing or more complicated things like like image like modification, stuff like that. So it was a big deal. It allowed you to basically use the parser to control commands on the computer. There was a whole bunch of stuff that it could do, but a lot of people used it to delete files, write files. Somehow, in extension, get remote code execution on the server is kind of the very top level explanation of this bug.
Nice, that's awesome. So, I mean, for those unfamiliar, this is going to be a pretty awesome find. So going through the blog post, one of the things that Andrei mentions kind of right up front is that he thinks it's a server-side request vulnerability. or forgery at the beginning of this. And from your perspective, why do you think that is? Why do you think that pops into his mind first?
You know, the first thing that I see that screams SSRF to me is when he was going through, you know, whatever site it was on Facebook, is he saw a redirect parameter. Now, Facebook's awesome at security. They've tied down a lot of the type of redirect vulnerabilities or SSRF vulnerabilities and stuff like that. But whenever I'm just testing any site in general and I see a parameter that contains either a domain or a web protocol or any protocol at all, the first thing I think in my mind that screams at me is SSRF, right? So that would be like, you can see maybe like 4 or 5 spaces down, he shows the image, and then he shows the link that he was kind of looking at. And so you can see that there's a parameter there called redirect_URI. And that's what screams to me, okay, I want to see, you know, and there's also a picture equals parameter there as well, and a link. So there's 3 possible areas here where you want to check for, you know, because they have a protocol specified and a domain, you want to check for SSRF. And so there's kind of 3 levels of SSRF you can get, which as an attacker you're really kind of hoping for, right? The most critical one is SSRF that leads to kind of LFI, the ability to use a protocol handler to read files off of the system and get that through the website. And that's like, you're so happy if you find that. That's great. And then the next one is internal SSRF without local file read allows you to do things like port scan the internal network, right? Using the website or the parser or whatever it is you're attacking to port scan the internal network, get information from the internal network. And you can use other protocols, not just you know, like HTTP when you're doing these SSR attacks to do tricky stuff. You could actually FTP to sites using that protocol handler and stuff like that if you format it. In fact, if you're doing SSRF, the kind of Bible for SSRF is actually called the SSRF cheat sheet / Bible. What it does is it tells you the stack you're testing against in a table and what kind of protocol handlers are most often enabled by default, and then how to exploit SSRF bugs. So that's the second level, is being able to port scan. The third level is, all right, well, I can't read files, I can't port scan, but can I get external service interaction? And a lot of testers are seeing this nowadays because it's actually included in Burp, right? Collaborator in Burp will tell you, hey, you know, we inserted a collaborator URL and all these parameters, and one actually called back to us because we can see that via DNS request. And so that's called external service interaction. It's a form of SSRF. A lot of times people are letting this fall, though, in their testing because they don't know how to exploit it. Now, in this case, because he was requesting an image, he was really smart to be like, all right, well, you know, the whole function of this parameter that might be vulnerable is actually to request an image. And I imagine that further down his thought process, he was like, well, you know, image tragic was a thing. Maybe if I provide a modified image, I could do something cool with this.
So let's take a quick tangent there. So the idea that hackers are letting it fall by the wayside because they don't really know how to exploit that external service interaction. What does that, like in a nutshell, what does that look like? Like if you were able to call out to another site, how do you take that to a new level?
Well, in this case, you know, you have to understand what actually is calling out. So if the normal function of the site is to load an image, that image has to be in some form parsed by a parser or stored in resident memory or loaded or, you know, stored in a file system. So, you know, when I test sites and there's like a profile picture, just for a file upload vuln, this is the kind of stuff you need to look for, right? If they're going to store that somewhere, if you can insert code anywhere, if you can either make that thing that they're going out to get an executable, that could be a vulnerability. If you can include something like this attack, which is shell commands inside of an image, that can be a vulnerability. If it's just doing a lookup and parsing text, you want to see if you can enable JavaScript, or if you can somehow get it to execute JavaScript. There's a lot of different ways to do that, but honestly, and I'm just going to be super honest here, a lot of when you get this external service interaction and the exploiting kind of path around it requires you to have your own attacker server. And this is actually where I see a ton of people who are separated, right? Like a lot of the really top-end hunters have their own DigitalOcean droplets or something where they host an attacker domain. They're ready to serve files for you know, two-step vulnerabilities, I like to call these, right? Where something requires you to have your own server for people to pull content off it. And when you're a new tester, you're just not to that level yet where you're hosting your own domain and you're ready to host malicious files to do two-stage attacks like this. And so this is kind of one of those level up moments when you're able to do this type of attack. So they'll just let the external service interaction alert go and burp, or if they see it themselves, they won't mess with it because it's not readily written about really anywhere, and
Right.
how you force that server to do anything. I guess does that make sense, kind of?
No, 100%. That's honestly that's exactly what I was trying to get at. And when I say get at, I mean confirm, right? Because 98% sure I knew kind of what was going on there. And I've seen reports, and I mean obviously at Shopify we do get some reports. But there's talk about the fact that you can talk to an external site, right? But that in and of itself, in my eyes, isn't necessarily the vulnerability, right? It's that second stage that you just kind of described, and I think that's a key takeaway for people that might start looking for these. It's great to be able to communicate out, and that might not be something that the site wants to happen. They might lock that down, but going from a medium severity to a higher critical severity, from what it would be in bug crowd, a P3 to let's say a P2 or P1, is that understanding of what's going on with the stack, where you can then leverage, say, local file inclusion and cross-site scripting, something else beyond just, hey, I'm talking to you server to server.
Yeah, I mean, there's awesome ways to leverage this. In fact, one of the ones we're going to talk about in the coming weeks is a CSP bypass that used a site that was whitelisted in their CSP, but then used a parameter like this to pull in an external script to bypass their CSP, right? And so there's all kinds of tricky things you can do when you're able to instigate web requests, basically. One of the things here is that I don't want to discount that you should never report external service interaction, because what you can do is now you can use that site as a proxy to port scan the external internet, and that's not great. That's not good for anyone. A lot of people want to know about that bug, but if you want to upgrade what usually is like a P4 or P3 bug to a P2 or P1 bug, you want to look for the next logical extension and exploit here. So
yeah. Cool. On that same note, before we kind of move away from the SSRF, he makes mention of the fact that he says it looks like it's a proper request from an isolated server, and I'm just curious if you could expand on that. What does he mean by isolated server?
It's sometimes hard when you read these write-ups to understand exactly what his thought process is.
Yeah.
It doesn't look like it's the same server that's requesting. It might be a different one. I actually don't know the answer to that question just from what he's writing here.
So then maybe does it make sense? This is kind of what I took away from it, and what we've looked at, here, is not necessarily having the request originate from, say, Facebook.com. But you have a separate server that is isolated, that's whole job is just doing that one thing. So it doesn't have access to personal identifying information, doesn't have access to any type of critical, let's say, functionality, arguably, in and of itself.
That could absolutely be
sense?
What he means here. Yeah, it does, yeah.
Okay, cool. So briefly, he also mentions the fact that there's this potential for parse SVG, and potentially a server-side request forgery from that, and sometimes leading to external entity, I can't even think of it, XXE, right? And so, what I take away from that is, and what I've been learning about recently is that SVGs are all written in XML, right?
Absolutely,
And so when you do that, you can parse and get external files, like access to external files. Is that kind of your takeaway from this as well? Parse SVG, kind of, if you don't have it locked down?
Yeah, I mean it's almost almost as bad as Image Tragic itself, honestly. External entities are a killer, man. No matter if they're enabled default on like a wide range of like XML parser, or in this case some type of image parser where the format is actually XML. It's a rough vulnerability, because as soon as you have that config wrong, it's instantly local file read. So which leads most of the time to code execution, because you can steal credentials or stuff like that. And God forbid the permissions on whatever app is running that library is high, then it's game over, really. So so I mean, it makes sense. He probably has a lot of experience with attacking parse SVG. I don't have a ton attacking that specific parser, but I do know, obviously, like you said, SVGs are written in XML. So if if the config is not set to exclude external entities, you just probably create an SVG file with a structure that loads an external entity, which does like file load, or a, the entity is a file, and then you can send that information off using the same kind of technique you would in external entity expansion injection, or XXE is external entity.
Yeah, I can't
XML,
remember. Exactly. It's like
yeah.
XML, external,
Okay, I do it
yada,
all
yada,
the
yada,
team, but
XXE,
it doesn't make sense to the acronym either. So anyway, but doing XXE, the same techniques you would use in blind XXE is smuggling out a file or some kind of content or something. So I'm sure he's really used to that, and he saw that, the payload of this URL request was normally supposed to be an image, and so he went down that road first because he has experience with it. But he was smart enough to be like, oh yeah, what other hardcore vulnerabilities have there been in image parsers? And what I would have done at this point too is, like, had I been smart enough to find this bug, is basically be like, ask that same question and then land on image tragic, right? Which was really a really big deal. So awesome job to him.
Yeah, exactly. Fundamental. I don't know if I would have made the jump. I'm also thinking, like, in hindsight, if I was being honest with myself, I'd probably sit there and be like, you know what, like, this is Facebook. Everyone's probably tried this out. So maybe, like, what's the point of wasting my time?
That is the worst thing. I hate it so much, Pete. I hate it. So we try to tell people, testers who are working with us, is just like, just because a program is public, or in this case, a site's bug bounty is public, like, it doesn't mean that all the bugs have been found. Obviously, you see these write-ups and you're like, oh, this guy's super smart, and obviously, this tester is really advanced, but you can still find bugs on hard to find sites, and giving up in the middle of some chain is not where you want to. It's not what you want to do. It's just follow your intuition. If something smells vulnerable, follow it through to the end. Kind of test it like you would in science, where you do a couple of experiments, and then if it doesn't pan out, then you can kind of give up, right? Like, but never in the middle of it should you say, oh, well, this is Facebook, it's probably not vulnerable. Everyone writes bad code, man. I write bad code, you write bad code. That's why we do this for a living, right? We need people to find it. So, and
it's there's two key things that I wanted to flag there, right? So first, it's, there's going to be a time investment to set it up, right? Like, so here, you've got to figure out, what payload are you going to be using for image tragic? Does it actually work? This kind of stuff. So there's going to be some upfront costs there, and that is going to suck kind of upfront. But where it doesn't is if you turn that into a learning opportunity, or set yourself up for that second stage, right, to become that upper tier hacker, where if you go through this, and rather than just go through the motions of, hey, I'm going to try image tragic, as opposed to, I'm going to set up my own server, I'm going to create the DNS entries for my own DNS server, I'm going to set up the image tragic files, all that kind of stuff. You invest in the next test, right? So what might be 10 to 15 minutes to test here this time, next time is 2 to 3 minutes, and so it's a lot easier to do.
Yeah. In fact, that's the same thing that the ASEs here do. It's like, in any time when I was testing mobile for HP, the hard part wasn't the work. It was getting the first couple of weeks getting your testing environment set up, right? Like, just to, like, what you want. Like in mobile, you have to have a jailbroken device and a rooted Android device, and then, like, get them proxied and figure out how you're going to deal with anti-jailbreak protections, and then get all of your tools on there like you would a standard Nix system. It's the same thing with web hacking, right? Like, this is part of your tool set now. It's burp, owning an external domain that you can use as an attacker domain, getting your I was just talking to a couple of my guys earlier today. Try not to test from your home system. I recently was on a bug bounty and blacklisted my home from eBay and PayPal, and because they were using Akamai as a WAF, and then my wife was trying to get on the computer, and she's like, why can't I get to PayPal? Why can't I? It was wide reaching too. It was like she was trying to register a hotel to go visit a friend, and she couldn't get to the hotel network because they used Akamai, and I had blacklisted us from the Akamai WAF. So anyway, key point there is use a droplet or some other infrastructure, not your own IP, to do some of this stuff. Yeah,
that is. I'm gonna have to switch some things up myself.
Yeah.
No, that's fair. So digging back, so at this point, he's kind of looking at things, and he makes reference to the fact that he's not able to kind of communicate out, and he thinks that the server might be firewalled. Um, what does that mean for somebody who has no clue about firewalls and certain a secure server setup and whatnot? Like, why does he think that this is firewalled? What does that necessarily mean to him?
100% I'm not exactly sure what he means, but what I'm inferring that he means is that many customers are really good at, or many companies are really good at external kind of DNS requests, and it's actually one of the core hygienes that my buddy Daniel Miesler, he's all into core security stuff. There are some fundamentals every company should be good at, and outbound DNS is one that not a lot of people are, but should really be good at, right? So what should this server be able to talk to? Is it anything? Is it certain domains? Just like in that idea with CSP, right? Like, what should we be allowing the server? And so, will this server talk to his attacker server if it's not a Facebook server? And that's maybe what he's thinking about here.
Right.
Are they blocking it? And then also, are they allowing IP notation, or do they need an actual DNS name, or what will this parser take as an input? There's a lot of things to be thinking about at this point in the attack. Am I going to be able to access my attacker server image? Am I going to be able to force the site to grab it? What restrictions are in place to stop this server from getting there? And then there was a SSRF in my bug bounty talk I did. There was a link to an SSRF talk that somebody did, and they had all of these strange notations to actually get to IPs or domains, but were not the standard protocol whatever. So you could do it in Octal, or you could do it in a whole bunch of different things, and eventually they would resolve in most parsers or most web browsers to the site that you wanted them to go to. And so those are some kind of tricks that you would think about here to, if there was a blacklist or a whitelist in place, that you would try to get around something like that. But I don't think in the end he encountered one, did he?
It's so I guess what I took away was he was trying to communicate over HTTPS, HTTP, your typical 80 or 443 calls. And the server's kind of locked down, but then it looks like he manages to kind of get a call out with a DNS lookup.
Okay, right? There we go. Yeah.
And so the DNS, for those that aren't aware, and you can correct me if I'm wrong, is going to go out on port 53, right? So this server isn't locked down from the DNS lookup, and so as a result, the way that DNS works, his server is going to kind of makes the call from Facebook, resolves to his attacker server looking for this weird long URL. I can't remember kind of what he's got off the top of it, but in the nutshell, it's going to try to resolve that. His server will communicate and say, hey, no, that doesn't work, which kind of takes it to the next point. Is his image is able to then say, take information and turn it into a subdomain, right? And that's essentially how he gets the exfiltration kind of happening, right? He's providing the image that's being parsed through ImageMagick, through the vulnerability. He's grabbing a file, reading the contents of it, and then appending that to what should be a subdomain on his attacker server. And the Facebook server calls out, essentially sending that information out to him. Have I got that right from what you understand on the write-up?
Yeah, absolutely. Yeah, I think that is absolutely right. It's almost like a 3-stage attack, honestly, at this point, right? To know that knowledge and convert that is something that, again, not a lot of people would do. So this is why this attack was so cool to talk about. Yeah.
And that point on kind of what people would know or not know, Neil from Facebook in the interactions that are shared in the write-up, he says, you might want to try base 64 encoding next time, or base 32 is more commonly used. And so again, correct me if I'm wrong, but the idea is you read your file, you can encode it in base 64. So rather than have the actual file contents and a bunch of extra, say, bytes, for lack of a better term, in there, you can standardize it to base 64 so that it's a little bit cleaner. You can get some more information out at each call, and that's kind of where the exploit goes, right?
Yeah, on the exfiltration side, a lot of people do that in XXE as well. Is they'll base 64 the data blob out, is because it's cleaner. Bytes don't get truncated across the internet. It's easier to get out what you need. Especially, also, you're not using as much data in the request as well. So yeah.
Nice. Okay.
And it also bypasses if they have some type of security technology that's looking at outbound requests with certain keywords or something like that, that might get stopped there. But if you base 64 or base 32 encode it, it will bypass a lot of those. So
Awesome.
yep.
Yeah, so I mean, I think that brings us to the end of the post. What I think is helpful is some key takeaways, right?
Yeah.
And so I'll throw mine out. You can kind of throw yours out.
Yeah.
But one of the things that I see from this is, if you see some type of URL that we talked about, immediately think about SSRF, right? And that it goes to the Hunt tool that you guys have released, right?
Yeah.
We haven't really talked about that, but you can touch on that. But before we leave, again, if you see image parsing, be on the lookout for, say, parse SVG, image tragic. Be conscious of kind of what's going on in that back end, especially when it comes to server-side request forgery. If you can understand the process and kind of what servers are doing, that allows you to elevate, say, a vulnerability from something that might be a P3, P4 to a P2, P1, right? Does that make sense?
Yeah, absolutely, yeah. Yeah, just don't accept it at face value, right? It's exciting to get it in and get into the system and have a bug, but like if you smell RCE, try to follow it through, right? It's worth more. And then a lot of the times, if someone finds the first level vulnerability, at least here at BugCrowd, right? Like we're trying to take care of the testers as much as possible. So let's say that you come in and you're like, there's SSRF here, external service interaction. That's a P4 on BugCrowd, right? I don't know off the top of my head what it is exactly, but let's say you submitted that, right? And then I come in after, and I'm like, yeah, there's an SSRF here, and then I use this second stage image tragic bug, and then I use another bug to exfiltrate data. The thing that we would do is advise the customer to actually pay out both testers, right? One came in first, and then one followed it through to a pretty hardcore exploit that had a high impact. And so we want to be fair to everyone, so that would be what we would advise the customer to do usually in that situation. Yeah, I mean, so don't stop, and don't think that the time limit is going to kill you. Like, in pen tests, you have all the time in the world to follow through on a bug, but in bug bounty, you're racing against the clock and other testers. But really follow it through. Yeah.
Cool. That's awesome advice. On that note, a quick question that kind of popped into my mind, and this is probably customer specific, so it may not be a general answer. But in those types of situations where a hacker kind of comes in and says, hey, SSRF, external service interaction, doesn't really take it to the full extent, but that second person comes in and does, the customer actually goes ahead and pays both. Does the customer sometimes go back to the first person and say, hey, this is what you could have done? Or like, have you seen that from your experience, or do your guys try to do that? Educate and kind of
not for specific customers, honestly. I'll just be honest. Not really, because it's just a kind of that vulnerability data. You don't want to spread it around and stuff like that. Usually, BugCrowd stuff is all non-disclosure unless the customer explicitly agrees in the comment system in order to disclose the bug. And so if they're that open and they're a really cool customer, there have been times where they're like, oh yeah, actually this worked, but it's very few and far between, honestly.
Okay, yeah. No, and that's what I was wondering. I didn't figure it would be odd for BugCrowd to kind of do it. But it would be cool to see the customers doing it and try to incentivize that from these types of conversations and telling them, how they can help other hackers. Because I mean, two hackers that have the skill set are better than one, at least from the company perspective. That I think.
What has happened is write-ups like this have come off when both researcher and customer agree, and they've done a disclosure, and the blog post comes out. I've seen some cool ones where actually the researcher and customer have gone into the blog post together and talked about the technology and be like, yeah, we received some reports on this, that were SSRF, and then but also you were the only one who took it to this level, and then so everybody gets the benefit of knowing, kind of like where the initial set of testing stopped, and then how the the tester who found the P1 or the really critical bug actually took it through to like something crazy. So they get that information and education, but it's not in the comment system usually at BugCrowd. Yeah.
Okay. Yeah. Cool. All right. That rounds it up for me. Are there any kind of closing comments from you? Any thoughts, takeaways that you haven't touched on?
Yeah. I've been doing a lot of talking, but
no.
I'm not trying to blatantly push my own tool because I don't want to do that. But one of the things in Hunt, we made this a burp extension called Hunt. And what Hunt does is it basically took the BugCrowd data set, only the parameters out of all of the bug bounties we've ever run that were most vulnerable to certain classes of vulnerabilities. So we have a section that's called possible server-side request forgery. And even if you don't use Hunt as a burp extension, I would suggest every new hunter go look at this JSON file where we have the config for our Hunt tool, and it tells you parameters which you should be looking at for these types of things. So URI and URL are two keywords that we alert on anytime we see passed in anything across burp, and we say, hey,
awesome.
it is possible here that this is indicative of server-side request forgery. You should go check this out. And then we give you like all of the cheat sheets we've ever found to be very useful on SSRF, right? And so these are parameters like destination, redirect, URI, path, continue, URL, window, next, data. I think there's like 25 of them that we identified that were kind of common in SFRF, and we do this for a whole bunch of different types of bugs as well. And so when you browse, it alerts you. But even if you don't want to use our burp extension, check out the issues.json file in that project, and just as a tester, keep it in the back of your mind to know that these are the type of things you should, the parameters that you should be looking for these bugs in. Because if I would have had this when I started as a tester, oh my God, it would have been so useful just to know inherently, or have some context around where these issues pop up initially on, when you're passing data through parameters. So, yeah.
It's I'm glad you mentioned that, because in our pre-recording here, you and I were talking, and Hunt came up. I'm glad you mentioned it, because again, in spirit of full disclosure, I haven't installed it yet, and I keep meaning to, and this will be the prompt for me to go do that. And the one thing that I wanted to share was, it's good to know about all this kind of stuff, but if you can automate kind of the mundane in the background, so that you don't have to worry about noticing those params, that something like Hunt can flag them for you.
Yeah.
I had a vuln that I submitted earlier this week, where it was James Kettle's idea of cross origin headers coming back, and going to any origin. So it didn't matter where you submitted it from, they always gave you that header back. And I almost missed it, except for the fact that there was a parameter that looked kind of odd, so I thought I'll actively scan that one single param. And when I did that, they flagged the origin header. And so I got lucky that way, almost missed it. So something like this with Hunt that will say to you, hey, look at the redirect URI or data or that kind of thing that we always see, or we've seen be associated with SSRF. It'll save you as a hacker.
Yeah, absolutely. And even if you don't like the data set that we provided, the Hunt tool is extensible. So all you have to do is add one line to the JSON and save the JSON file, and then it'll start scanning for that parameter too. It's very simple to extend. So let's say that you at Shopify have a custom stack or something like that, and you've received to your bug bounty a lot of reports based on one input into your application, which is either a parameter or like some type of field or whatever. You can add that to Hunt via one line, and then when you're spidering, every place is showing up throughout all views, all websites if you've deployed the code base across multiple domains. So it's really useful to both testers and people. Like, we just kind of wanted to level up a ton of people, and this is useful to us. Like, I have personally found, like, I would say 35 to 40 bugs just using Hunt to remind me to look at things, right? Because it's just like you said, I'm like floating around. I have, and I'm big into discovery, so I actually have like 100 domains on a wide scope test that I'm looking at, that I'm like, all right, well, I'm going to check all these. And as I'm in burp, it's just, I can definitely, like 50% of the time, miss a good parameter that I should be fuzzing for some random reason. And so as soon as Hunt tells me, it's like, hey, I located all of these, go check them out. I put them back into, just like you said, into Intruder, and then actively scan defined insertion points or something like that in burp. That's a way to do it. You can use your own custom fuzz list in Intruder. You could just send that whole request to Scanner if you wanted to scan every parameter there. But it just helps you kind of like keep track and make sure you don't miss those juicy params that might have something to do with them in them. So yeah. Sweet. Yeah.
All right. We were originally targeting for 15 to 20 minutes, but we hit the 30-minute mark, which is, for me personally, it's awesome. I think there was a lot to talk about. No. This is. I think this is great. There was a lot to talk about. A lot of key takeaways. Hopefully, you see some uptakes there in Hunt being installed. I'm not sure if Burp allows you to track that, but that'd be kind of cool. So just to kind of round it out, this was first kind of deep dive. I think you and I have some scheduled up until the end of the year, so it should be kind of once a month, time permitting, based on our schedules. So hopefully listeners will be on the lookout for that. And we'll sign off now from Shopify and from Bug Crowd.
Later, everyone.
Thanks very much. All right, that was awesome.